So I figured it'd be good to do some examples of word problems. Then I'm hoping we'll start the next section, which is chapter 4, the next chapter, excuse me, which is chapter 4. And that will be percents. So here's the first problem. Now the names here, I don't know if they're the same names as in the book, but I kind of chose the names randomly. So the first one says that Ariel has saved up $3,500 for her summer visit to Seattle. You know, Seattle's a big city in Washington state. And now she anticipates she's going to have to she's spending $400 per week, each week that is, on rent, food, and fun. So the question is, how long can she afford to stay in Seattle? Okay, so this is the question now. Okay, so we basically have completed the first step, well, almost at least. We read the problem, right? So, okay, so what quantities are changing values? What quantities are changing, that is? Well, how much money she has, you know, she's staying there, she's spending money. You know, that's given in the problem. She's spending about $400 per week. Okay, and of course, also time is changing, right? You know, as time goes on, she's staying there. So okay, so those are two changing quantities. So we're going to use notation for those. I'm going to let capital M be how much money she has remaining. Okay, and X is how many weeks she's been there. So X is time, but notice though that she's spending a certain amount each week. So here the unit of time is basically in weeks. So that's why I put X in weeks. Okay, so that's for number one. Now, what are we trying to do? We want to know how long she can afford to stay here, right? Well, she can only stay until she runs out of money, right? You know, once she runs out of money, she has to leave Seattle and go back to her hometown, wherever that is. So we want to know how long she can stay until she runs out of money. In terms of our notation, we're saying that we want to know when capital M is 0. You know, M is how much money she has, right? So initially, M is going to be this $3,500. And we want to know when M is 0. That's what we're trying to figure out. Okay, that's good. So that's what we're trying to find now. Okay, so we know that, there we go. So we know that she has $3,500, right? So that means M initially is $3,500. We want to know when M is 0. Okay, what else is given to us? She's spending $400 per week. And now X also is in weeks, right? So in terms of our notation, if you increase X by 1, so as a week goes by, in other words, M is going to decrease by 3,500. So let me say that again. Since X is in weeks, right? If we increase X by 1, then capital M will decrease by 400. And that's basically telling us M is going to change at a constant rate. What I'm also doing here is I'm just doing some calculations just to help illustrate what's happening. So for instance, I'm just trying some numbers to help illustrate what's going on. So when M is 0, M again is how much money she has, right? When M is 0, she has $3,500, her starting value, okay? When M is 1, what does that mean? A week has gone by and she spent $400, right? So how much does she have left? 3,500 minus 400, which is 3,100. Okay, that's 1 week. Now let's say another week goes by and she spent, another week has gone by, so we know she spent another 400. So how much does she have now? 3,100, right? After week 1 minus 400, which is this. And then let's say another week goes by. She again spends 400, so she starts out at the beginning of week 3 with $2,700. She spent $400 throughout the week, and she's now left with this amount. And I mean, we could keep doing this, okay? We could. However, what is really going on here? Well, every time we're increasing x by 1, our input by 1, m is getting smaller, it's decreasing by 400. It's decreasing by the same amount each time. So it's decreasing at a constant rate. M is a linear function, and that's what I'm saying over here. But now the question is, okay, what's a formula for m? Well, the calculations can tell us that. Namely, we know m of 0 is 3,500. After week 1, she has 3,500 minus 400 times 1. So this is x equals 1. It goes here. And now for week 2, we know it's 3,100 minus 400. Now you could substitute, which is what I'm doing here. Which is 3,500 minus 400 times 2. In other words, she's spending another $400, right? And that's really what I'm saying here. She's spending $400 twice. So m of 2 would be this. Here, let me get that pen. Come on. There we go. 2. 2. Okay. 1. Oh, wait, I went over. Oh, boy. 1. M of 3, well, again, she spends another 400. I mean, you could take the m of 2, which is what I did, and minus 400 from it. And that's the same thing as taking m of 2, which is this. No, they can't see that. And minusing 400. I mean, I didn't write it here, which was my mistake, but basically m of 3 is going to be 3,500 minus 400 times 3. So in other words, we're going to get this. It appears that's what's happening. So we have a formula for m of x. You know, don't be afraid to try some numbers here. That'll help you understand what's going on. And as you can see from the pattern, we can come up with a formula. So now we have our formula. Now, before I keep going, are there any questions so far? Okay. Okay. So remember how we said, let me go back a bit. We said that we want to know when she can stay until she runs out of money, right? We want to know when m is equal to 0. I didn't write it down, but I'm pretty sure I said it. So we want to know when this is going to be 0. So to solve the problem, we want to know when this is true. Because m of x, again, is how much money she has. She can only stay until that money she has is 0, until she runs out of money. And that's what I'm doing here. Right? So we want to solve this equation for x. X is how long she can stay. And that's what I'm doing here. This is just basic algebra. Okay? And you know, I said 0 equal to this, m of x. We want to get x all alone, so I add 400 to each side. Let me get the wonderful pen. Right? And these cancel. So we get 400x equals 3,500. But we want to get x all alone, so we divide by 400. These are going to cancel, and we get x equals 35 over 4. And that turns out to be about 8.75. So she can stay about 8 8.75 weeks, so a little less than 9 weeks she can stay. I mean, we could have, I guess, theoretically keep going with these calculations until we got to M of 8. Then M of 9, we would see she would run out of money. So that would tell us that if we just did these calculations, we could approximate how long she'll stay, which would be somewhere between 8 and 9 weeks. But this way, we get the exact answer. So, okay. I know word problems can be tricky. I understand that. I mean, I like to do word problems. I mean, in the past, I haven't tested people on them. At least nothing as intense as this. But I still think it's good for everyone to see them. What questions do you have about this? Okay. Let me pause the recording and we'll keep going.